73 AD. High on cliffs that rise almost vertically above the Dead Sea, the fortress of Masada stood on heights so steep that almost no army could hope to take it. Up there, a small band of Jewish rebels, the Sicarii, dug in, ready to face any force that dared to climb. For the Romans, masters of siege warfare, Masada was unlike anything they had ever encountered. Sheer cliffs made ladders and ramps nearly useless. A single narrow path snaked up the mountain, easily defended and impossible to deploy a large army. Thick stone walls fully stocked food supplies, and defenders determined to fight to the last man. Every tactic the Romans had spent centuries mastering to storm a fortress, completely useless here. For the first time in the 1st century, they faced a problem that demanded a decisive solution, a siege weapon that would become a defining symbol of Roman military ingenuity. Welcome to Heroic History, where we bring you incredible stories of ancient warfare every single day. Hit subscribe, join our community, and let's uncover the secrets behind history's most legendary battles. So here is the question: how could a single siege machine change the fate of a fortress that had never been taken? How did the Romans turn sheer cliffs into a battlefield? And why does Masada still echo through history as a story of brilliant strategy, desperate struggle, and sheer human will? Let's find out. After Jerusalem fell in 70 AD, Masada became the last bastion of Jewish resistance, home to a radical faction known as the Sicarii, led by Eleazar ben Yair. As long as Masada held, the rebellion lived. Its position added to its significance. From the summit, one could see far across the Dead Sea and watch the trade routes that cut through the Judean wilderness below. Whoever controlled Masada controlled the eastern approach to Judea. That made it not just a physical stronghold, but a strategic keystone in the defense of the region. In ancient Hebrew, Masada means fortress, and the name couldn't be more fitting. The stronghold sat on top of a rhomboid-shaped mesa measuring roughly 550 mm by 270 mm, protected on all sides by brutal cliffs, 400 m straight down on the eastern face and another 90 m on the west. Reaching the summit was almost impossible. Only 3 narrow, winding paths led up, most famously the twisting snake path, and each route could be defended by just a handful of men because attackers had to move in single file. In many ways, Masada was practically siege-proof. Around the edge of the mesa ran a 1,400-meter casemate wall, roughly 4 meters thick and 4 mm high, wrapped around the plateau like a suit of stone armor. More than 30 towers and 4 tightly controlled gates broke up the wall, turning the entire perimeter into one massive defensive machine. Inside, Masada was a self-contained city. At the northern tip stood a complex of lavish palaces, decorated with Roman-style frescoes, detailed mosaics, and even terraced bathhouses carved into the cliffs. Scattered around the interior were more than a dozen vast storerooms capable of holding as much as 2,700 tons of food. And in a desert where water was life, Masada had a system that bordered on miraculous. Rainwater was funneled across the slopes through aqueducts into giant rock-cut cisterns, large enough to keep over 1,000 people alive for 2 to 3 years, even in the dry, punishing Judean climate. To the Romans then, crushing Masada wasn't just a military operation, it was a political imperative, and the events that followed would make that brutally clear. Marching eastward came Lucius Flavius Silva, a seasoned and calculating Roman general chosen not merely for rank, but for his precision in siege warfare. Born into a senatorial family in Ubisaglia, Italy, he was appointed governor, legatus of Judea, between 72 and 81 AD, the man entrusted with ending the First Jewish War decisively. In a theater like Judea, where politics and control mattered as much as battlefield victory, Silva was Rome's ideal instrument. With him came Legio Ex Fretensis, Rome's tool of strategic dominance in the East, a unit forged through civil war, Eastern campaigns, and brutal urban fighting. Their banner carried the name of Caesar. Their history carried the weight of conquest from Gaul to Jerusalem. This legion had evolved into a specialist force in siegecraft, experts at building fortified camps under fire, raising siege ramps in terrain no sane engineer would touch, and deploying artillery with almost surgical precision. Unlike legions trained primarily for open field battles, the 10th had spent years fighting in the cramped alleys and fortified towns of Judea. They knew how to break rebels who hid behind stone walls, steep cliffs, and religious conviction. Indeed, Legio X had played a central role in the siege of Jerusalem, 66-70 AD, famous for their deployment of massive war machines capable of hurling 25 kiloton stones more than 400 meters, battering walls before infantry assaults. They had mastered mass construction in heat, dust, famine, and unending rebel ambushes. And there is one single weapon that gives the Romans that reputation. Its roots go all the way back to the engineers of ancient Greece. But once the Romans got their hands on it, everything changed. They refined it, standardized it, mass-produced it, and turned it into one of the most decisive and recognizable mechanical weapons in Roman warfare, the ballista. So, what made this thing so feared? What made it more than just an oversized bow? The earliest ancestor of the ballista was the Greek gastrophetes, literally a belly bow. It was a heavy crossbow you braced against your stomach to pull back. The Greeks scaled that idea into something larger called the oxybeles, a powerful bolt thrower mounted on a wooden frame. These early versions relied on simple tension, just like a gigantic bow. But then came a breakthrough. Greek engineers replaced the bending wooden limbs with torsion springs, thick bundles of twisted fibers, usually made from animal sinew. Think of them as giant elastic coils. The tighter you twisted them, the more energy they stored. And when that energy was released, the arms snapped forward with explosive force. When Rome absorbed Greek territories, they didn't overlook this invention. Roman engineers studied it carefully, experimented with it, tweaked every component and tested it again and again. Eventually, they created a standardized model that was stronger, more compact, easier to transport, and, just as important, simple to manufacture in large numbers. This is the moment when the ballista truly became Roman, and to understand why it was so powerful, you have to imagine its mechanics from the inside out. Their proper Roman ballista began with a heavy wooden frame, usually made from oak or another strong hardwood, built to absorb enormous mechanical stress. Metal plates and iron bolts reinforced the key joints so the entire structure wouldn't tear itself apart when it fired. Running straight down the middle was the slider, a long wooden track where the bolt or stone sat before launch. You can imagine it as the ancient equivalent of a cannon barrel, centuries before gunpowder existed. On both sides of the frame stood two thick vertical posts. Inside each post was a round torsion housing, like a wooden drum built directly into the structure. These circular chambers held the heart of the machine. Each housing contained a huge bundle of twisted sinew, the famous skeins. These were tightly packed cords made from animal tendons that had been soaked, dried, twisted, and compressed until they could hold astonishing amounts of tension. A solid wooden throwing arm passed straight through each bundle, one arm on the left and one on the right. When the crew pulled the arms backward, the skeins twisted tighter and tighter, storing massive energy. The Romans even developed adjustable bronze or iron end caps with locking pins that allowed engineers to fine-tune the spring tension. This meant they could perfectly balance both sides, which was essential for accuracy. It also let them adjust the machine depending on the weather, because sinew absorbs moisture, and its stiffness changes with humidity. And yes, Roman engineers actually monitored humidity because a ballista could misfire if the springs weren't tuned correctly. The throwing arms themselves were usually carved from tough hardwood, and sometimes reinforced with metal bands so they wouldn't crack under pressure. A thick rope or cable connected the arms to a large winch mechanism at the back of the machine. To prepare for a shot, the crew attached the winch to the arms. They turned the handles, slowly pulling the arms backward. As the arms moved, the torsion springs twisted tighter and tighter. A ratchet locked everything into place until it was time to fire. When the trigger, a simple but incredibly reliable metal latch, was released, the arms snapped forward with violent speed, unleashing all that stored torsion energy in a single explosive moment. That force traveled straight into the projectile, and if you happened to be in its path, your day was about to get a whole lot worse. Roman ballistae weren't just brute force machines, they were surprisingly precise tools. Many were mounted on sturdy platforms that allowed fine adjustments, raising or lowering the angle for range rotating side to side for targeting, and even using shock-absorbing beams to handle recoil. The ballista could fire several types of ammunition, giant bolts, often more than a meter long, heavy arrows designed to smash through shield walls, rounded stones weighing anywhere from 10 to 60 lelbi, about 4.5 to 27 kilos, and in rare cases, clay pots filled with incendiary material. A large fortress-grade ballista could launch a 27-kilo stone nearly 500 yd, roughly 457 meter, or the length of 5 football fields, and it could repeat that shot again and again. Some experimental reconstructions even suggest that a skilled crew could fire multiple shots per minute, and a special repeating variant, the polybolos, could reach around 11 bolts per minute, almost like a mechanical machine gun of its time. Unlike trebuchets or catapults, which lobbed stones in high arcs, the ballista fired in a nearly straight line. It acted like ancient sniping artillery. Roman writers even bragged that a ballista could pick off individual men. Now imagine an entire line of Roman artillery doing that at once. A single bolt from a large ballista could skewer a man, punch straight through a shield, or splinter wooden defenses. Stone projectiles could smash battlements or sweep defenders off parapets with terrifying force. And there was something especially frightening about it. You often couldn't see or hear the shot until it hit. When Roman bolts started slamming into a position, enemy morale often broke long before the infantry ever reached the walls. But no weapon is perfect. The torsion springs needed constant maintenance because sinew stretched or warped when exposed to moisture. Building a ballista required skilled carpenters, blacksmiths, and trained engineers. Reloading took time since the crew had to winch the arms back for every shot, and the larger models were heavy and slow to deploy. Even so, the ballista gave Rome something no other ancient empire had on such a massive scale: standardized, mobile, precision battlefield artillery. And that made them uniquely qualified to attempt something close to impossible: the siege of Masada. In the autumn of 72 AD, Lucius Flavius Silva marched his force from Jerusalem and surrounding forts across Judea toward Masada, the final pocket of Jewish resistance. Josephus tells us Silva brought with him somewhere between 8,000 and 9,000 fighting men. But when you add the support crews, slaves, camp followers, and engineers, the entire column swelled to roughly 15,000 people. That meant the Romans outnumbered the 960 zealots on the Mesa by more than 15 to 1. Those are the kinds of odds Rome liked, and they weren't coming empty-handed. Legio Exfratensis arrived carrying all the precision tools of Roman siege warfare. They had ballistae and scorpions ready to hammer the defenders on the plateau with heavy bolts and stones. Archaeologists have found at least 53 ballista projectiles around Masada, ranging from light shots of about 0.66 kilos to heavier stones weighing 22 kilos. Most of them were concentrated along the western side, exactly where the Romans were preparing their main assault. Behind the artillery came the heavier machinery, a massive battering ram, the Ares, enclosed inside a towering siege engine that looked like a wooden house on wheels. And supporting all of this was an entire tool chest of Roman engineering: beams for scaffolding, pulleys for lifting, picks for cutting rock, shovels for earthworks, protective mantlets for advancing under fire. All of it organized and maintained by the Fabri, Rome's professional military engineers, the unsung technicians who kept the empire's war machine running. But the big question was, what exactly were they planning to do with all of it? Before they could even think about reaching the top of Masada, Silva had to make sure no one could escape and no one could help the defenders. So while the army marched along the Judean plateau and descended toward the Dead Sea Basin, they fanned out and settled around the base of the isolated mesa. There they built 8 square, disciplined camps, neatly labeled A through H. Each camp had a specific purpose. One oversaw the main supply lines, another housed reinforcements. Others guarded escape routes or stood ready to repel any desperate rescue attempt from the countryside. Camp F, the largest, served as Silva's headquarters and the logistical heart of the siege. Connecting all 8 camps was the Romans' next marvel, a complete circumvallation wall known as the Limes. Picture a stone perimeter stretching 11 kilometers, almost 7 mi, encircling the entire base of Masada. It was 1.5 meter thick and stood 3 to 4 m high, tall enough to stop a breakout force and steady enough to support patrols. 15 watchtowers dotted the line, giving the Romans a full view of every movement on the mesa and in the desert below. Josephus describes it as a massive undertaking, and modern archaeology backs him up. The whole perimeter took only 2 to 3 weeks to construct. But trapping the fortress was just the beginning. Masada itself was the real problem. Its eastern and southern cliffs plunged straight down, 400 ms on one side, 90 ms on the other. Sheer drops that made any assault suicidal. For a moment, even the Romans must have looked up and wondered how they were supposed to get a siege engine up there. And then Silver spotted it. On the western side, a natural ridge jutted out from the desert floor, the White Spur, or Luke. It wasn't gentle by any means, but compared to the other faces of the mesa, it was the closest thing to a weakness. This became the foundation for Rome's most ambitious construction project in the entire campaign. Here, the engineers began building a colossal siege ramp, a man-made causeway of stone, rubble, packed earth, and wooden supports. It eventually rose 60 meter, about 200 ft high, and depending on how you measure it, stretched somewhere between 200 and 600 meters in length, and it was broad enough to carry not just infantry, but an entire siege tower with a battering ram inside. The work wasn't easy. The heat of the Judean desert could melt the willpower of even a hardened legionary. All the while, the defenders on the mesa hurled rocks, launched arrows, and sent down whatever missiles they could to slow the construction. And yet, here is the part that still amazes archaeologists today. The Romans completed the entire ramp in 11 to 16 days. That's less than 3 weeks to build an ascending road of solid earth high enough to reach a fortress that had defied every enemy before them. It took a workforce of 6,000 to 8,000 soldiers, all laboring in rotating shifts, all protected by mobile shields and mantlets as they built under fire. Modern surveys confirm everything Josephus described: the height, the slope, the scale, and the breathtaking speed of its construction. And all of that groundwork set the stage for what came next: the arrival of one of the most intimidating pieces of Roman engineering ever built. Once the ramp reached its full height, the Romans rolled into place a siege tower that was just as impressive. This thing stood close to 18 men tall, around 60 cubits in ancient measurement. It wasn't some flimsy wooden shell thrown together in a rush. Roman engineers had calculated every single dimension. They built the base wide and heavy, so the tower wouldn't tip under its own weight. They wrapped the outside in iron plates bolted onto its wooden frame, both to shield against flaming arrows and to absorb the impact of falling stones from above. Inside, multiple floors held everything from archers to artillery crews. Getting a machine of that size up the ramp wasn't a simple matter of pushing. It required hundreds of legionaries working in careful coordination. Large wooden rollers were placed under the structure to help it inch forward. Teams of men pulled ropes, others cranked winches, while senior engineers walked alongside the wheels, checking the earthen ramp for soft spots. One collapse, one shift in the foundation, and the entire plan could have ended in disaster. Every few feet they had to stop, reinforce the ground, double-check angles, and then wait for the signal to move again. But eventually, after days of this slow grind upward, the tower reached its firing position near the top of the ramp. Now, the Romans had something extraordinary, an offensive platform that stood nearly level with Masada's western walls. And that was exactly what the engineers had been aiming for. They wanted the tower to reach a point where the troops inside could engage defenders almost eye to eye. The moment the structure settled into place, the ballista crews took over. Their machines, secured on reinforced wooden platforms inside the upper levels, were now perfectly aligned with the fortress walls. And that was exactly what the engineers wanted from the start. Not just a tower, but a stable firing stage for the Empire's most precise and terrifying weapon. Before the battering ram ever swung, the ballistae would open the show. Stone projectiles, huge dense chunks weighing 10 to 15 kilos, around 20 to 33 lb, shot forward with a violent snap of torsion power. Each release was like uncorking a thunderclap. The stones didn't just hit the fortifications. They smashed against them with enough force to make defenders flinch long before any breach appeared. Above them, mounted on the very top tier of the tower, Roman engineers placed the Scorpiones, lighter, faster bolt throwers built for surgical accuracy. If the ballistae were the sledgehammers, the scorpions were the snipers. A zealot archer might peek over the parapet for a heartbeat, just long enough to ready a shot, and that was enough. A Roman bolt, iron-tipped and flying nearly flat, would strike before he even finished drawing the string. As the tower edged forward inch by inch, these engines kept up a steady rhythm of fire. The zealots on the wall were under constant pressure. Every time they tried to throw down firepots or drop stones, the ballistae and scorpions answered with a volley that sent them scrambling for cover. The tower itself was almost impossible to burn. Roman engineers had draped it in soaked animal hides, which smothered flames before they could spread. Arrows hit the iron plating and bounced off. Firebrands fizzled uselessly against the wet leather. And above, Roman archers protected inside the tower kept watch for anyone attempting to set the machine ablaze. Behind the main line, additional ballistae were set up on stable platforms. Their job was to target the higher battlements, pounding the upper defenses, and making it increasingly difficult for anyone atop Masada to mount an effective counterattack. Each shot was adjusted with small tweaks, raising the angle by a degree, shifting the aim by a hand's width. Based on decades of combined battlefield experience, the ballista crews worked in shifts, almost like a factory. At any given time, one team was cranking the arms back with a winch. Another was slotting in the next bolt or stone, while a third group checked the sinew springs for heat damage or wear. In the desert climate, wooden frames swelled during the morning, dried at midday, and shrank at night. If a spring loosened, if a frame warped even slightly, accuracy would drop. So maintenance was constant, almost as important as firing. And through all this, the artillery never stopped. Shot after shot, bolt after bolt, a heartbeat of war that echoed across the canyon. After 1 week, the wall finally gave way with a groan, as if Masada itself were exhaling its last breath. A section of the outer fortifications collapsed inward, spilling stone and timber down the steep cliff, raising choking clouds of dust that swept across the slope. The ground trembled beneath the impact. Modern excavations confirm this moment. Burnt beams, shattered masonry, and collapse patterns all match Josephus's account. The breach had been made. A path now lay open through Masada's outer defenses. But the Romans did not rush in. Flavius Silva held his men back. He had seen too much in Judea to be fooled by a broken wall. At Jotapata, defenders had poured scalding oil on attackers. At Gamla, they had funneled Roman soldiers into narrow, deadly kill zones. In Jerusalem, every house was a fortress and every alley a trap. A shattered wall could be an invitation or a death sentence. Masada's defenders, the Sicarii, were no ordinary soldiers. They were zealots, survivors of Jerusalem's fall, men and women who had chosen exile on a cliff rather than surrender. They had nothing left to lose. So Silva gave the order: halt. It was safer to wait for light, for order, for clarity. At first light, the Romans advanced. Columns of legionaries moved with caution through the broken casemate wall. They expected barricades, fire, resistance, but encountered none. Shields raised in testudo formation, eyes scanning for movement. They pressed forward. Engineers inspected the breach. Tribunes and centurions directed squads deeper into the fortress. And then they saw them, men, women, children, hundreds huddled in the stone chambers. Josephus records the words of Eleazar ben Yair, the leader of the Sicarii. On that final night, he had addressed the people of Masada, urging them to choose death over slavery. "Let us die," he said, "unenslaved by our enemies and leave this world as free men." They had agreed. They cast lots. 10 men were chosen to carry out the grim duty, moving from room to room and ending the lives of their kin. Then the 10 drew lots again. 1 man remained, and when it was done, he turned the sword upon himself. When the Romans arrived, there was no one left to fight. Inside the fortress, they found only a few survivors. 2 women and 5 children huddled deep within the stone cisterns, trembling as they whispered the story of the final night. From them, the Romans learned the truth. There had been no last stand, no final clash of steel. only a collective, deliberate, and unspeakably resolute decision. Nearly 960 men, women, and children had chosen to die by their own hands rather than submit to Roman chains. Fathers took the lives of their own families. 10 men were selected by lot to finish the rest, and finally the last man ended his own life. In the aftermath, Roman soldiers, likely shaken even in victory, cleared the site. They stripped the fortress of what remained and dismantled the siege engines that had carved their scars into the mountainside. Thanks for sticking with me until the very end. Let me know what you think in the comments. And don't forget to like, subscribe, and hit that notification bell. I'll see you in the next video tomorrow.